In this problem, we initially have 2.4 cubic meters of gas at standard temperature and pressure. Standard temperature is 0 degrees Celsius, is 273 Kelvin, and 1 atmosphere of pressure. Now we're told that it compresses down to 1.6 cubic meters and the temperature is raised by 30 degrees. So 273 plus 30 gives us 303 Kelvin. We're asked what is the final pressure. So pretty straightforward problem. PV equals nRT. Okay, that's our ideal gas law, where R is a constant, N is a number of moles, and PV and T are pressure, volume, temperature. Now, we have PV and T as knowns and unknowns here, and we know N and R is a constant, and the number of moles doesn't change, because this is the same setup, same here, same here. So N and R are both constants in this case, our initial and final case. So we can say, let's solve PV divide T over, so that we're left with just the constants. Those are going to remain the same for the initial and final part. So we have initial, final. So we can say that NR initial equals NR final, so that NR initial equals NR final. NR is just PV over T. P initial, V initial, over T initial equals P final, V final, over T final. Okay, the only thing we don't know here is our final pressure, which is what we're looking for. So we solve for P. Final equals PI, VI, TF over TI, VF. So, final pressure when we plug in initial pressure, 1 atmosphere. V initial, 2.4 cubic meters. T final, 303 Kelvin. Divided by initial temperature of 273 Kelvin. And our final volume of 1.6 cubic meters. Okay, now for significant figures for this final answer, it's not 1 because this is a known number, so it's 1 exactly. Standard temperature and pressure is 1.0000, and our temperature 273 is fixed. So our 2.4, our givens are what we have to worry about. 2.4, 1.6. And that's 2 decimal places, or sorry, 2 significant figures. So multiplying this out, dividing this, gives us 1.7 atmospheres. So we'll notice that our Kelvin canceled, cubic meters canceled, we're left with atmospheres. So our final pressure is 1.7 atmospheres. Final answer.